In this particular example here, we can see that we have a domain which is stated in terms of ordered pairs, and same thing with a codomain. The point here is it's no different in terms of how we come up with it. So I'll just draw this out so that we can see that we can still do this. We have an element of 0, we have 1, and we have 2. Those are the only inputs. Then in the codomain, which in this case it is going to be on 2, because the only thing that we have here as far as what the codomain is just the output values. So we have a 7, we have an 8, this is another 7, we have a 9, and we have a 10. So 0 maps to the elements 7 and 8, 1 maps to the elements 7 and 8, and 9, and 2 maps to the element 10. Now, the domain we know is 0, 1, 2. The codomain, well, we just have the ordered pairs to go off of, so we just have to assume it's 7, 8, 9, and 10, which means the range is the same. Is this a function? No, it's definitely not, right? Because 0 and 1 have multiple outputs. And so since it's not a function, we don't need to worry about onto or one-to-one, right? Because it's not a function, well, that means it can't be one-to-one. Because to be one-to-one means that every input has one output and every output has one input. And it can't really be on 2 because it's not a function. So onto is something we can only talk about with respect to functions. Now let's take a look at a mathematical one. When we're looking at functions, in algebra, unless otherwise stated, the domain and the codomain are always all real numbers. Okay? As a basis point, at least the codomain is always all real numbers. Now the domain, in our case, is this function we know from algebra. We'll always look at our domain in terms of what can you not plug in. Well, clearly we can't plug in x equals 0, and that's the only number that you can't have in the denominator. So we would say all real except 0. Another way you could write that is the set of all real numbers, set difference minus the element 0. Okay, that's another way you could write that. Okay, so that actually just ensures that every input is going to have exactly one output, right? The element 0 is just not allowed to be plugged into that function. So we can still call this a function, but when we define our domain, we always omit the elements that just cannot go into that algebraic function. What's the range? Well, the codomain, remember, is all real numbers because the idea is that an output is always just going to be a real number. It may not be an integer. There are values that you could plug in that would produce an integer, really just 1. If you plugged in 1 for x, you get an output of 1. But if you plugged in 5, you would get an output of 0.2. Okay, that's no longer an integer. If you plugged in pi, you'd have 1 divided by pi, and that would be an irrational number. And that is still a real number. So this function, when you take 1 and divide it by a number, you're going to get a real number as an output. Now the range is asking, what real numbers can you actually get as outputs? Well, notice that this function goes up forever, and this function goes down forever as x approaches 0. The idea here is that x, if it's really, really close to 0, 1 divided by a number really, really close to 0 is going to be really, really large, either positive large or negative large. So we have a range that goes down to negative infinity and up to positive infinity, right? Another way you could think about this as in terms of domain is everything going this way along the x-axis except x equals 0. We'll put a little circle there, open circle, just meaning that we can't plug in 0 for x. And now our range, which I'll do in red to distinguish it, notice I can generate anything up here, and I can generate anything going down here except y equals 0. The idea is you can't divide 1, theoretically, mathematically, there's nothing you can divide 1 by, no number large enough that will give you an output of exactly 0. So our domain will be all real numbers except 0. So that already tells you this function is not on 2. The codomain is all real numbers by definition. The range is only the real numbers that we can generate by given some input value. And those two are not the same. Is this a function? Well, yes, it is. It's an algebraic one. Any value that you plug in for x, 1 divided by that number, will always be a single value, right? 1 divided by 5 is not going to give you 0.2 and something else. Every input will give you 1 output. Namely, every 1 input in the domain will give you exactly 1 output in the codomain. Is it 1-to-1? Okay, well, let's think about this. Every input has 1 output. Does every output have 1 input? Well, let's see. If I pick this one here, that's going to correspond to just that input right there. If I pick this output right here, whatever that is, that's going to just have 1 input that generates it. This output right here will have exactly 1 input that will generate it. Every single output value links back to 1 input value. Every output value leads to 1 input value. Now, you may have heard this called the vertical and horizontal line test. The vertical line test just says that if you can vertically slice through the function at any given value of x, and it only slices through the function one time, there's only one intersection point, that means it is a function. The horizontal test says that if you draw a horizontal line through the function at any value of y, whether it be here or here or here or wherever, if there's only one intersection point everywhere, now it might seem like when you draw a vertical line or a horizontal line here that there's multiple intersections, but this is a curve, it just starts to look flat. It will only intersect one time. So this is still a 1-to-1 function. Now another way you could see that, and I think this is a better way of doing it, is solve for x in this equation. Okay. Now, if you just take the reciprocal of both sides, if y over 1 equals 1 over x, then 1 over y equals x over 1, which means that x is equal to 1 over y. So you could answer this question, does every output generate 1 input, by saying, hey, if I plug in a value of y, do I get exactly 1x? Well, if I take 1 and I divide it by any integer other than 0, do I just generate one number? Well, yes. There's only one number of times, or a single number of times that y can go into 1. So algebraically, it's a little bit easier to see, but the vertical line test and the horizontal line test are just more visual ways of assessing whether something is a function and whether it's 1-to-1.